Today we are going to introduce two more libraries for plotting. One is the Seaborn, and the first one is Seaborn. So oftentimes we have to summarize the data first and then plot the data, like the Coursera data set we used for our previous assignments. So you have to summarize how many courses that each institution offer, what is the average score institution for institution. Right? So if you use the plot, the library, math plot library, we mentioned on Monday, then you have to summarize the data and then plot it. So Seaborn, this library help us to do both jobs in one code. I'll use the Coursera library, for example, as an example. So I imported it, and the first thing we want to do is to summarize the average score of each rating score of each institution. So please notice that this Seaborn library is built on the Matplotlib library. So you have to import this as well when you use the Seaborn. But it's really similar to how we use the Matplotlib library. It's just like a library name, and then it's the method bar plot, and then you tell it the data for the x-axis and the data for y-axis, and then the data frame. So the x-axis I want to use is the rating score, right? But here, because it has so many institutions, I want to use the horizontal bars. So I want to put the institution on the y-axis, and then the rating score on the x-axis. So I try this rating, and the y is the institutions. And data is still this data frame, df. And here you have to set up the estimator. Estimator is like the aggregation function we mentioned for the estimator equals a numpy mean. So I need to get the average score, so it's a mean. What else? I think that's all we need here. Okay, yes. So the position, the direction, orient is horizontal. Okay, then you have to use, so this is built on the Matplotlib library, so you still have to run the code, show this part. Let's see how it look like. Okay, so this gives us this plot. Okay, it looks pretty good. Maybe we can squeeze it a little bit instead of having the bins so big. You can use the height. I believe it's the height variable parameters that set up the bins. No, it's not the height. Get back. get back to check the parameters. So it doesn't have a parameter height. It's actually the white. So I'll try the white. Still doesn't work. Okay. Let's just leave it here. Then I believe it should be the parameter white as it says here. I'm not sure why it doesn't work. Okay. But if we want to change this figure and set it up, set up the height and the width, and there's another way to customize it. That is the figure size. You can define the figure size using the PLT figure size. So this is it. Check back. Okay, so now this figure is a little bit shorter, better. Okay, one thing I want to explain here is you see some black lines here. So this is the average score, right? This number is the average rating score. So these black lines means that the range of this column for this categorical value. So like the Google one, probably a little bit over this. This average score is let's see. The max value. See here. So this is more clear. So this one, remember we had some outliers like 8, 7. So this black line means the max number and the smallest number. Yeah, the max number and the smallest number, and this is the average score we use to plot the data. And also sometimes, oftentimes we want to change it to a grouped bar chart. If you want to change it to a grouped bar chart, you can add the parameter hue. That's for the group bar chart. So here, for example, I can add the level as another dimension. So it will be transformed to a grouped bar chart or a stacked bar chart. Okay, so this is the Seaborn, and if we want to plot the number of course offering for each institution, then you can do this. Use this method, cat plot, and the data frame is still, and the X or Y, I believe it. I want to horizontal. I want it to be horizontal, so it should be Y. Let's try. And this type should be count. Okay. That's all we need. Okay. Oh, this is the graph for the number of course offering for each institution. It's too small, so we can try to set up the figure size again. And for this one, I believe it has a height. Try the height parameter. Okay, yes, so it worked. It did change the size a little bit, so that's good. Okay, just leave it there, and you can try the different parameters to set up the best size for the figure. And also, if you use the Seaborn for plotting histogram and plotting the scatter plot, you can add the fitting line for the scatter plot. So that's another bonus, another difference from the math plot library. So for example, this plot the rating. And then I can use this parameter KDE that will add the density curve. Let's see. So this is a histogram. A little bit. Yeah, the shape is a little bit strange, and we can customize the bin width and customize the figure size, like what we did. So the same way we can bin width. I'm not sure what value is best for this figure. Let's try this. So actually, it looks pretty good. So the beam-wise setup, I set up the value as 0.2. So each beam is 0.2 steps. The interval for each beam is 0.2 now. Good. So the next one, next library we introduce is the Plotly, which can be used for map plot, like the assignments in this week. You have the WHO data for for the population from all the countries, or the population growth in each country, right? So in this case, the map plot will be perfect, but will be very expensive. So this is the plot library. You should install Plot and the Plot Express. And let's load this data. This is a US data for US crime rate. And actually, it's quite straightforward, so I'm not going to run it. I'll just explain this code. So this is the data for the crime instance, number of crime instances in each state, and also it has another variable years. So so we can use the state as a dimension, and also the year as a dimension. Yeah, so you can see like the instance, the number of instances in each state each year. So plot let us create this kind of interactive map. You can see the number of crime instances for the state, for each state, and if you move the years, and you can see the number of instances, the change of the crime rates in each year. So this is pretty cool, and it can be used in many cases. And it's very straightforward. The parameters is very straightforward. The location is a variable. The categorical feature you use for location. Like here, I use this is a state, right? The state. But they don't use this state name. Instead, they use this state code as a location, as a parameter to set up the parameter for the location. Okay. And for countries, you have the country code. And the color is the numerical value for crime rate, right? So the color the feature we want to use for this parameter. So if the rate is higher, the color should be darker, right? So the feature we want to use for the color is the moderate. Animation frame, you can add it, or you don't have to add it if it's just one dimensional, like in 1 year, the crime rate in 1 year, we don't have to add this. But if we have two dimension, like the year, you can interact at the bottom with the bar, scrolling bar. Then you can set up the year to this parameter. And color, there are a lot of color scales. This is the default one. I just commented it out and use the default one. Location mode, this is US state. We just copy this code. And the scope could be world, USA, Europe, Asia. There are a few options. This one, the map we use is the USA. The range color is just the range of the this column. You don't have to set up it. By default, I believe it's the minimum value and the maximum value. Okay, that's all the parameters we need. And if you run this code, and it will give you a map like this, and you can interact with the map. We see looks these years, 1980s, the number of crimes is higher than the other years. Like in 2010, it goes purple. The map goes purple. So I mean, the fewer or smaller murder rate. So that's pretty cool. And if you use the WHO map for your project, you can use this this library to create a map plot. And the next one shows the word. If you create a word map, obviously, the only thing you have to change here is the scope. You change this to a word. And the location, you change it to another code. So usually it's a country code. ISO alpha, that's the country code for the featured countries. So don't use this country. Okay, use this country code. There are really so many libraries available for plotting. So just and then imagine what kind of graph you want for this, for your data, for your question, and then just search on Google, and it will tell you, hey, what library you can use to plot your graph. We really cannot cover all these in 1 week. So just leave those for you to explore on your own. And the next one I want to talk about, so we talk about this. Just observe the data and tell yourself what you want to tell from the data and what kind of graph you want to visualize, what kind of a graph you want to create, and then choose a chart. And then when you format it, don't forget to tell your audience have the labels and the titles to tell your audience the essential information about your chart. Okay. Next one I want to talk about is how to communicate your result effectively. So you have the data here. So what do you find? You have the graph there. What do you find from the graph? That's also very important to communicate with your audience. And there's like some clues that you can use to explain the graphs. For example, for the line chart, here is an example of India's sex ratio and birth in the recent years. So what can we tell from this graph? Here. Okay, and right up, it comes down again. We cannot just tell this. What else do you read out? So usually, first thing we tell is the trend. It goes up from this year, and I peak at this year, and after this year, it comes back. So usually, first thing you tell from the line chart is the trend, and then with the trend, you can describe whether this increase is slow or whether it's sharp, dramatic. That's the second one you can tell in the line chart, and also tell the peak and the bottom. This is the peak, and this is the point of the change, the bottom. So from here we can see, like in this year 1971, this started to rise tremendously because abortion was legalized in that year, and it peaked a year, and after this year it comes back, and it explained it because there's a campaign for the Save the Girl Child case. So this January you can follow this this clue. First is a trend, and whether this trend, this increase is slow or tremendous, and then explain the peak and the bottom from the line chart. Okay, find this website. Now this is a consulting research group, think tank, right? Think tank. The publication on this website, they're very good and have good graphs, and also have good explanation of the data. So when you do work on your project, read some articles from this website and learn how to explain the graph. Okay. And if it's a multiple line chart, how we explain the data. So like the single line chart, usually we goes, like you write an article, usually you goes from a general and then explain each key point. So if it's a multiple line chart, same. Like this one is the rating of Congress. This represents the two groups, and this is the overall, the total ratings. So what you do is first is explain the total trend, and then it goes to the each group and compare whether they're you can explain the total first, and then explain each group, and then toward the end you can compare the difference between these two groups. So it's like it's really like you're writing an article, right? It's about line chart. So for each example, I have the link there, and you can read how they explain this. Okay, I think these articles are really beautiful. For bar chart, it's really like a line chart. You can compare the different groups and highlight the highest group and the lowest group, and whether the significance between the group is big. The difference between the group is significant or not. And group the bar chart. Group the bar chart. So group the bar chart, you can do two things. First, because group of bar chart gives us two dimensions, right? Gives us two categories. You use the two category feature for the group bar chart usually. Right? This is like by the difference between teens and the adults, and then the difference between two political groups. So we can compare the teens with the numerical value for the teens between the teens and the adults, and then compare this group and then the demographic group. So from this chart we can see the adults, generally the teens are more comfortable. Safe space online. So generally the these are comfortable, right? The teens are higher than this one, these adults. So the teens are more comfortable with the online. They're more confident in safe space online than the adults. And we compare these two groups, red with the green. Compare the red with green, and I think the democratic groups are more confident in safe space online than this one. So compare the groups horizontally and vertically. Okay. For example, if we use this one, this one, then you compare between the person, is a person, and then compare in each group between between each state, if there's any difference, right? Use both dimensions. Pie chart, it's quite straightforward. So you just have to explain the percentage of each group. But when you explain the percentage of each group, you can also follow a logical order. You can go from the largest piece from the smallest piece. Okay. Histogram. Histogram, there are three things you can highlight about. You can look into for a histogram. Usually, first is the center of the data. That means the average number for the data. So, and the shape. For example, this one is the survival time. So the average survival time it's either here probably 500 days. That's the average survival time. And then the shape of the data. This one, it doesn't follow the normal distribution. Instead, it's a screwed left, which means more people died within this 1,000 days, and fewer people can survive. This is probability, right? This probability is high. So more people died within 1,000 days, and fewer people can live over 1,500 days. And the spread, also you can explain the spread. It's from 0 to 3,000. I think that's because this research, they only calculated to 3,000 as the maximum dates they used. And any outliers you can mention also. That's a histogram. Scatter plot. So for a scatter plot, there are 4 things you can mention also. First is whether the relationship is positive or negative. There is one, when this BMI with some body index. This BMLI value increases, this fat value also increases. So it's a positive relationship, and whether this relationship is strong or not. In this map, pretty much all centered to this line. So the relationship is strong, but oftentimes like the one in our assignment, it's all the dots are scattered. So the relationship is really not that strong or very weak. It doesn't, it indicates some relationship, but you're not very confident, right? So the second one you can mention is the relationship, the strength of the relationship. And third one is if this relationship is linear or curved. Curved means it's a quadratic relationship, means x and plus x squared. And last one is the outliers. So if there's any outlier, you have to explain it. So this is an example, and there's also another example here. Means means people's views confidence in the vice president, and whether it's associated with their confidence in the president. And that's a very interesting article you can explore also. I think there's a problem accessing. Yes, so here you can see. This is the confidence in Biden, the confidence in Harris. And you see this also, yeah, shows a strong relationship. So one thing we have to be aware of is a strong relationship doesn't mean causal relationship. Here in this article, of course, you will not come to the conclude a causal relationship. These are do not cause to each other. But like this one, in this map, in this case, it's a BMI. I think it's body, something about the, yeah. So okay, let's see it here. So for example, if this is a scatter plot, that means that your time of sleep, how many hours you get sleep, and whether this person is healthy or not. Okay, you may think, hey, yeah, sleepiness, the hour you sleep does cause your health, right? And that has a strong relationship with your health and may cause your health, but you cannot come to that conclusion. Okay, most patients, the relationship you can not come to doesn't mean a causal relationship. Only with the experiment, control the experiment, and then you may conclude that. But with an existing data set, you cannot, you should not indicate a causal relationship, like one variable cause the other one. Okay. So this concludes our lesson today. Really hope to save some time for you to finish this week's assignments, and whenever you finish that, start the project as soon as possible, because that takes 15% of the final grade. So I ask you to find a data set on your own. If you cannot find anything, I think the WHO data set is still good, because we only use the 2 variables, and there's 100 variables you can use for your project. And also, you learn to explain the data professionally. Refer to the publications on this website. Okay. Yes, Alex.
I just want to get your opinion on something.
Okay.